Welcome to our second video on electricity. This one's going to be on alternating and direct currents. So our goals from this video are, one, be able to explain the difference between alternating and direct currents, and later on we're actually going to analyze the pros and cons of each. The first current we're going to talk about is direct current. Direct current is what we call unidirectional. And what that means is it only goes one way. It's like a one-way road or a one-way street. This is just like batteries and circuits or anything with your remote controls in your Xbox, PlayStation, anything like that. So if we take a look down here at the bottom, we have our battery in our circuit. The battery emits electrons, they flow through, they keep going, and they go through this one way. They just keep cycling through this one path. That's all they do. One way, unidirectional. This was made famous by Thomas Edison. Thomas Edison is the one that really tried to use this with their houses and almost powering towns with it. He almost did it exclusively with direct current. But what happened is this man came along, and his name was Nikola Tesla. And he came up with this thing called alternating current. Nikola Tesla actually now has a car named after him, the Tesla. So, alternating current's a little bit different. As its name states, it alternates back and forth. It's bidirectional, two directions. Goes back and forth, alternates back and forth, left, right, left, right. This is what we use in our houses today. And we use what's called 60 hertz, which means that it alternates, it flips 60 times per second. Not per minute, per second. So the electricity switches 60 times per second. And we can see that with our little lab activities here. So we're going to first go to direct current, one path. If you take a look at the electrons here, this is using our little PHET activity, P-H-E-T. You can see the electrons are going one way, just one direction. That's it. There's no fancy alternating back and forth. There's one direction. There's flow. Here's a little, let's call it an energizer. Alternating current, on the other hand, switches back and forth. And we can see that over here. You can see the electrons don't really move very far, but they're alternating back and forth, back and forth. Remember, this is a scaled version. These electrons would actually be going so much faster. The one thing you probably see that's different is these light bulbs. These light bulbs are flashing. They're not steadily on like our direct current. What the difference is that when these switch directions, for a fraction of a second, they're actually stopped. They're dead stopped. But inside, the light bulb stays glowing for that fraction of a second. The light stays there. You can't see the difference in between on and off that quickly. So remember, we talked about alternating current is 60 hertz. It changes 60 times per second. This, our little AC battery here, is only going about one time every second. It's changing one time every second. We can bump it up to 2 times a second. That's the most that the program can hold. So we can see that they're flashing a lot quicker now. Now imagine this times 30. You wouldn't be able to tell the difference between flashing or on and off. It would just be constant on. And that's what happens in your houses. You can't tell the difference between on and off. You can't tell the difference, but you can't tell when the electrons are switching back and forth. So we're going to jump to another program in a second, but I'm going to show you how this is done. And we can remember that like forces repel each other, electrons repel electrons, and opposite forces attract each other. So we've been talking about magnets a little bit, and alternating current is made with very big magnets moving very quickly. And we're going to go to our program over here. And this is a magnet right here, North Pole, South Pole. You can kind of think of this as positive, negative. Here's a wire coil with electrons in it. If we start moving this magnet, it starts to move the electrons back and forth. If you follow them, they go back and forth. The magnet moves them. So this is how power companies work with alternating current. They have a giant magnet that rotates very quickly, and it moves the electrons and wires nearby. This is how alternating current is made. So once again, you can see the light bulb is flashing, nothing very special. If we crank this up quite a bit, to 100 revolutions per minute, it's getting harder to see when it's off. Now, This is going at 100 RPMs per minute. To get to 60 hertz, which is 60 times per second, so we have to figure that one out. It's 60 times per second, and this is in minutes. So we take 60 times 60, and it actually comes out to be 3,600 revolutions per minute. So we would have to multiply this by 36 times to get the actual speed of what a magnet travels at in a real power company. Just something to think about with how electricity is made and brought from a power company into your house so you can cook your Hot Pocket. Okay, this is what you're going to need to know from today's little talk and video. Direct current, one direction, DC. Alternating current, AC. Switches back and forth. Those are the simple ideas that we've gone over today. You're also going to need to know how alternating current is made with that spinning magnet and knowing that like forces repel each other and opposite forces attract. And the last thing everybody needs to know is AC/DC is one of the best bands ever. And thank you very much to the University of Colorado for allowing me to use their PhET interactive simulations. I've put the link to their website below, which has dozens of great simulations.